Hi, and welcome to this short tutorial that summarizes how to interpret a pressure relaxation curve in the context of speech breathing. So what we see here is a pressure relaxation curve, or at least a modified version of one, the one I like to use in class, which is a little different than the traditional one you see in a lot of textbooks. Recall that we have vital capacity or lung volume on the x-axis here, with it's a little reversed in terms of its scaling, so that low lung volumes is over towards the right and high lung volumes is over to the left. And on the y-axis we have alveolar pressure. And recall that what we do in one of the main goals of speech breathing is to establish a relatively constant positive alveolar pressure during the expiratory limb of the breath cycle. We need to do that in order to have enough pressure to force the vocal folds into oscillation, to apply enough pressure for release bursts associated with plosives and necessary intraoral pressures for production of sound sources associated with sounds such as fricatives. And recall that the means by which we modify or modulate alveolar pressure is by what we can do is vary lung volume. So when we breathe, we basically have the capacity to vary lung volume and then use changing lung volumes to establish alveolar pressure. Just a little reminder that typically our pressure goals that we're typically looking for in speech is somewhere around 8 to 10 centimeters of water pressure. And as you notice, this line here, right here, this line establishes a pressure. So if you think about this, we're going to be inspiring, expiring, and at the same time we need to be establishing a relatively constant pressure. It's also important to recognize that our target alveolar pressure is being about 8 to 10 centimeters of water. We also have to realize that the respiratory system is elastic in nature in the sense that it behaves like a spring. And just like any spring, we have a resting position where the respiratory system will go to if it's does not have any external forces being applied to it. And that if we displace that elastic system away from its rest, there are going to be recoil forces that are going to try and oppose that displacement. So in the case of a typical upright person, recall that somewhere between 35 and 40% lung volume, or vital capacity, is roughly the relaxation point of the system. So this is the point where there is essentially zero alveolar pressure being generated by the chest wall or by the respiratory system, because this is the relaxation state. As we move in either direction towards the right, by compressing the lung volume lower than its relaxation or resting state, we're going to have a response, a recoil force that is negative in nature, that's going to want to bring air back into the system to get back up to the resting lung volume or resting expiratory end level. Similarly, if we inflate the lungs to a level that's higher than resting expiratory end level or resting lung volume, there's going to be a positive pressure that's going to want to bring the system back toward resting position, so an expiratory gesture. So positive and negative relaxation pressure, as represented by this red line, simply represents the passive properties of the respiratory system due to its inherent elasticity. Now let's think about what we're going to do if we actually have to generate a constant subglottal pressure target or alveolar pressure target during expiration. Let's say, for example, we start at 40% vital capacity and we draw air into roughly approximately 60% vital capacity. So this is how much air we bring into the lungs, and if you watch as I draw this line up, you'll see that it roughly coincides, or it intersects, the relaxation pressure here, and this vertical line intersect, and also intersects with the target pressure. That suggests that the relaxation pressure, the pressure generated by the elasticity of the system, roughly matches the target pressure for producing alveolar pressure. So during the initial part of the exhalation, one needs not to add any net muscular activity right at this point because we're getting most of this by the simple recoil forces of the system. But also recognize that as we start moving back towards, as we expire and head back towards our resting lung volume, we are going to see that as lung volume decreases, the actual size or magnitude of the relaxation pressure starts to decrease. And therefore, we're going to need to add extra force there. And that force would come about by adding actually expiratory muscle pressure. So you can see that initially that pressure is going to be smaller, but as we get closer and closer to the resting expiratory end level, the degree or the amount of muscle force applied has to be greater and greater, such that by the end of this breath, we actually are attributing all of our alveolar pressure to muscular effort. Now let's consider a case where we continue to speak and need to maintain this same target level past the resting expiratory end level. In this case, we're still trying to maintain pressure, and we're going to need to continue producing to this particular target value. We're still going to need to continue to produce expiratory pressures to maintain positive alveolar pressure, but also note that we now at these lower volumes have a negative relaxation pressure. That means we have to add even an additional amount of expiratory muscle activity, not only to generate the positive alveolar pressure, but offset the opposing pressures by the relaxation of the system. So the system wants to bounce back up to 40%, and we have to overcome that with muscle effort. We know this is very difficult to speak at very, very low lung volumes. Most of us experience the amount of effort that we have to apply. So in this case, we have below REL, or our resting expiratory end level, the relaxation pressure is less than 0 and therefore opposes our positive pressure requirements for speech. And therefore, we have to produce a lot of muscular effort just to simply establish adequate pressures for speaking. Now let's think of a different situation where instead we take a larger inspiratory breath. So instead of going to approximately 60% here, we move up to somewhere around 75 or 80% of our vital capacity. In this particular case, you can see that the relaxation pressure demarcated here by this red line is actually higher than the target pressure that we want to establish for speech. In this case, we need to then provide a muscular offset to prevent the relaxation pressure from giving us too much pressure. In this case, we use a muscle activation, but in this case, it's going to be inspiratory muscles. So we're actually going to use this to put brakes on the system because we have a relaxation pressure that is larger than we need. So we need to have a net negative muscle pressure, and that would be accomplished by using the inspiratory muscles. So there's this interesting kind of paradoxical situation here at high lung volumes where we actually have to use larger or use inspiratory muscles to achieve adequate expiratory pressure. Hope this was a little bit of help to you and in terms of understanding this complex process.